Okay, quick video to deal with a couple of queries about factorization. Now, the factorization 9m squared minus k squared was mentioned. Now, although I was told, well, this is for Casper. Although I was told Casper knows how to do this one, I thought it's important to mention it anyway. Because it's an important standard form. Now, if you think of x minus y times x plus y, multiplying that out, you get x times x is x squared. You get plus x times y, this x times this y. You get minus x times y, this minus y times this x. And you get minus y times y gives you minus y squared, and then the two middle terms cancel each other out because it's plus and minus the same thing. So that just boils down to x squared minus y squared. So the reverse of that is if you've got the difference between two square quantities, it factorizes out as the two original quantities plus and minus one of them in the brackets. So, for example, if you've got x squared minus 16, it factorizes out as two brackets, x and x, and then the square root of 16 is 4. So 4 and 4. So the square root of 16 of x squared is x, the square root of 16 is 4, and in the brackets plus and minus. And that's a kind of standard result, a standard factorization. X squared minus y squared factorizes out in that way. So in the case of 9m squared minus k squared, in the brackets, we've got two brackets. The square root of k squared is k. And the square root of 9m squared, well, 3m times 3m will give you 9m squared. So in the brackets, you've got 3m plus k, 3m minus k. So that's the factorization of that, and you can multiply that back out to confirm that for yourself. But just worth remembering that standard result for the difference between two squares if you weren't aware of that. Now, I was asked about 12xy squared minus 6y. Well, that's not the difference between two squares. It's not a quadratic because it's got x and y both in it. So you just need to sort of do it in the more conventional way of factorizing something. You have a bracket and something outside the bracket, and then you need to think, what's the biggest thing I can divide these brackets by? Well, I can certainly divide, not these brackets by, these terms by. I can certainly divide everything by 6 here, because this is 6y and this is 12 something, and 12 divides by 6. So I can divide everything by 6 and take it outside the bracket. I can't divide everything by something with x because there's no x in the second term. But the first term's got a y squared in it and the second term's got a y in it, so I can certainly divide everything by y. So what I need to do is think of what is the biggest thing I can divide each term by. In this case it's 6y, and then I take that outside the bracket. And then I need to think, what do I need to multiply the 6y by to put in the bracket to get the original term. Not very well explained, but hopefully it will be clear. So what do I need to multiply 6y by to get 12xy squared? Well, I need to multiply it by 2 to get the 12. I need to multiply it by x to get the x. Then I need to multiply the y by another y to get y squared. And then the next term, minus there, what do I need to multiply the 6y by to get 6y? Well, obviously just 1. So the factorization of 12xy squared is, the 12x y squared minus 6y is 6y outside the brackets, and then inside the brackets 2xy minus 1. And you can work that back to check it. 6y times 2xy will give you 12xy squared, and 6y times minus 1 will give you minus 6y. That is fully factorized because we've taken as much as we can outside the brackets. It would have been partially factorized, for example, if I'd said, well, okay, I notice everything can divide by 2, so I'll take 2 outside the brackets, and 2 times 6xy squared minus 3y will give us the 12x y squared minus 6y. So that's a factorization, but it's not a full factorization because I haven't taken as much as I can outside the brackets. I hope that clears something up.